Resin print's cracking so bad, I think I've got a headache. Supports that somehow always find a way. Big blobs of doom that make you want to get a revo. And a fan submission of a person that's having some really rough issues with build plate adhesion. All this and more, PrintFix Friday, episode 30. Let's get into it. Hey guys, welcome back to PrintFix Friday, episode 30, where we got a couple of resin fails coming up first. We've got one that just looks like the layers have just ripped apart. Then we move into one that is similar, but just one rather than a bunch. From there we move into supports finding a way, as they tend to, a massive blob of doom, and then wonderful story from a fan that reached out that, yeah, we got them all fixed. Let's get into it right after a word from our sponsor, 3D Musketeers. If you are tired of fails, we understand they happen. It's a fact of life. But if you're tired of having a trash can full of failures, one, send us some photos using the hashtag PrintFix. Just add us on all the social medias, which will be right kind of in this general vicinity. You can reach out to the pros at 3D Musketeers. We have almost 40 3D printers to help you make awesome any day, anytime, anyway, ranging all the way from your standard FDM printers like you see behind me, all the way to full color sandstone, polyjet, and maybe some other technologies. We are here to help you make awesome. And even if you have just a light problem that you're dealing with, hit us up, DM us on Twitter, Instagram, whatever. I'm always here to help, and I'm the guy that answers all the questions. So if you want to ask me something directly, you can do it there. But if you want to interact with us on the daily, you can do so at patreon.com/3dmusketeers, where you can join our Discord server at the $10 tier or higher to come hang out with all the other Musketeers. But enough of the call to actions. They bother me, and I'm sorry. I guess I'm supposed to say like and subscribe. It helps based on the metrics that we find, but whatever. Anyways, fails and fixing them. Let's do it. What could have caused this? Printed on an LCD printer on FEP. Wolverine? Honestly, that's a hilarious answer. It would have been great for last week's PrintFix Friday, where we had a bit of a troll episode because it happened to come out on the 1st of April. I'm trying to see if we have any other settings. One of the big things here that I'd like to point out is when you are asking for help, whether it's on Reddit or Facebook, God forbid it's Facebook, I refuse to go there at this point. It is a problem child of help. But make sure that you're putting your settings and things in the actual comments, because if you don't have that, we are kind of flying just a little bit blind, and yeah, it's not exactly my specialty. I can do it, but we have a much higher chance of knocking it out of the park when we kind of know what's going on here, right? So looking at this fail, it appears that we have some separation on the layers as the print is occurring, and we can see that there's also some interior structure that I don't think is going to cause too many issues. But what I'm not immediately seeing, and a lot of that is because I can't tell, is drain holes. I would agree with this individual here that the peel forces were too high and tore the model and lifting from the FEP. This is absolutely something that could be happening here. But also, if you're dealing with something where you're printing it stuck onto the build plate, or maybe you don't have it hollowed well enough, or with at least 2 drain holes to let air in and resin out, you might end up with a bit of a cavity and a suction cup causing cavitation. A great way to verify that you don't have this issue is to use UV tools. We actually did a whole video on UV tools, and it might be worth doing some follow-ups on it because there's so much more that UV tools is getting day after day after day as they are doing tons of updates to this software. So if you guys want to see more UV tools content, let me know in those comments, and maybe we can add it to the content calendar. This is complicated, right? There are a lot of potential problems. If it is a regular LCD printer, we have to also assume that maybe they have a little bit too high cure times as well, causing it to cure to the FEP. LCD printers are going to run somewhere between 8 and 14 seconds, whereas monochromatic LCD printers will run somewhere in the 2 to 3 second range. So a much wider range on the regular LCD printers, but that does mean it is a little bit easier to go overboard on some of the resins. Something to keep in mind. I do want to give a shout out to Chris Catlett over on Twitter. They've been tagging us in some of these fails, this one and the next one we're about to go into. Thanks, dude, for helping us out. It makes my life just a little bit easier when people help curate this content. So please do feel free to add us on the social medias so we can take a look at all this stuff for you. The next one is kind of similar, but there are a couple of other things that I'd like to point out here. We can see some white residue, and people have talked about this a lot. This residue is due to exposure settings. Where it's white like that, that's from a cleaning issue, but the rest of it is from exposure settings. You got to dial in those exposures. Let's see if we got lucky here. We are seeing that it was not hollow, which, okay, there's a big thing here. That's a massive surface area. And the larger your surface area is, the more suction force that it's going to have to the actual build plate itself, right? When the resin is trying to pull off and away from the FEP, it's having to physically rip it. And especially on larger mono printers, you'll actually be able to audibly hear it go rip, rip, rip every few seconds. But I'm fairly certain this is going to be due to a mixture of a little bit of an exposure issue as well as a surface area issue. This model would absolutely benefit from being hollowed out, 100% benefit from being hollowed. We could easily hollow on the underside of the head and then maybe put a hole in the ear, maybe in whatever that front piece is, and you could easily fill those holes later with a little bit of raw resin and a syringe with a blunt tip needle. Don't use a sharp needle. I feel like we can, deal with that. Or you can use some of these wax tools that you can get at most hardware supply stores. These ones we get from Harbor Freight. They're also great for ripping support material off. You can put a little dab of resin on it, flow over the hole, hit it with a UV light, instantly cure it. It's a great way to do those things. And if you need it to be a little bit thicker, mix a little bit of cornstarch in there and that will thicken it up to be more like Bondo. Just don't eat the forbidden taffy. I've seen this once before. This issue of the weird layers that appear to be ripping apart, and it was because we believe an overexposure issue. But I'm not certain on that one because I've never personally dealt with it, so I don't really have a ton of experience on how to solve it. But we can also see that we have a distinct color shift where this is considerably lighter and inside is darker. And that leads me to believe that this also wasn't cleaned all of that well. And that's what I think some of this white residue is. It's leftover resin mixed with cleaning fluid that was cured. Now, they might have just said, screw it, I'm taking it out and curing it because the model's obviously failed, but I'm not certain. Something to check in on. It's not too big of an issue, but a big solid model like that is a fair bit of resin. My condolences. Supports failed successfully. I love when this stuff happens. It's happened to us a few times, even in time lapses. And there's one running right behind me. It's always fun when you guys get to see that stuff happening. This is a product we can't talk about just yet. Make sure you get subscribed because if we get permission, we'll be able to talk about it here pretty damn soon. But this is where the supports came detached from the build plate. We can see that the individual is using what appears to be some sort of glue to help the model stick down, but it ended up being okay. Something that I'd like to point out though is the model isn't without flaws. But before we get to the Z-axis banding, let's talk about this build plate. This is the carbonium stuff. I still will never get the stuff pronounced right, and I honestly don't care because I don't like it. It is effectively silicon carbide that is welded to the glass. For those that are uninitiated, silicon carbide, otherwise known as sandpaper, is considerably harder than the brass nozzle that you're using. So for some reason, you are a little bit too close and your brass nozzle happens to slide across that glass build plate, you have sanded your nozzle down, effectively changing your Z offset. Something to keep in mind there. However, in some cases like this, even poor adhesion can still lead to success. If you build up enough spaghetti, sometimes you get a little lucky, so you're not upsetty spaghetti. But as we talked about, this print, while still a success from a support level, is still technically not great. Let's look at this. So, one, marble filaments and other semi-translucent filaments will hide imperfections amazingly well. If you're dealing with some imperfections on your printer and you do need to do like a mission critical component, whether it's for a job, to show off to a friend, whatever it might be, you can look at using a semi-translucent filament that should remedy the situation for you, make life a little bit easier. But we are seeing some banding here in the z-axis. It looks like it's kind of due to inconsistent extrusion, but this also brings up the point of why I still to this day absolutely think that white filament is the worst color on the planet. And while this does have a little bit of speckle material mixed into it, I'm still a little wary that the fact that it's still a white base is not helping out here at all. When you do see z-axis banding like this, it is great to check your belts and make sure that your belts are tight. They shouldn't be too twangy. Some people say there's a certain frequency you should tune them to. I just tighten them till it feels right. I know that that is an absolutely terrible thing to say, and I'm sorry. I wish I had a better solution for you, but I've been doing it long enough. I just kind of know. And if you're using a printer with a spring-based belt tensioner, remove the stupid thing and do a hard belt tensioning system, because the spring is going to bring in slop, some of the slop that you see here. I don't think this is actually caused by the z-axis, although it could be. Fairly certain it's not. I believe this is more caused from axes moving ever so slightly during acceleration and deceleration movements. So how do you solve that? You want to make sure that you look at tightening those belts a little bit, making sure that your extrusion multiplier is set correctly by checking your steps per millimeter. You can adjust your steps per millimeter, you can adjust your extrusion multiplier. It kind of depends. I like to adjust the steps per millimeter first and then look at extrusion multiplier, but that's my personal feeling. We can also see that we've got a little bit of over extrusion on the solid layers themselves, maybe even a bit of an elephant's foot that was sanded down, and that is again indicative of a bit of over extrusion. But if we look at this first layer, we can see there's a little bit of glue on there. Glue should be used more as a way to break away material rather than stick it to a plate. Don't get me wrong, back in the day when we ran printers like the printer that you saw me light on fire in the previous Wednesday video, we'll card to that so you guys can take a look. That was a bit of a crazy video trying to show thermal runaway that was a failure in and of itself. But the glue was really only there because we had crappy bed leveling. We didn't do a good job leveling the bed, and therefore we said, screw it, we're just gonna cheat and use glue. You shouldn't need it, but I'm not really 100% in tune with the methods at which to clean these glass plates. Normally we say soap and hot water should generally do it well, and then you hold it at the edges like you would a vinyl record. For you zoomers out there, I don't know, don't touch the middle of it, just touch the sides. Just touch the sides. It's not operation, I want you to touch the sides, not the middle. At E3D Online, wow, that Revo sure is tempting right now. I'm going to need some F's in the chat here. Oh, God bless America. We've been over these blobs of doom more times than I care to count, but this one just hurt me especially because not only is it a blob of doom, it's a blob of doom that pushed the damn silicone sock off of it. So you are really feeling the heat. It's not fun. One of the best things you can do here is heat up the printer within 15 degrees of its max temperature and just leave it alone. Now, if it is a printer with a PTFE lined hot end, be careful to not go above 240C sustained because that can start to wear out that PTFE liner. But if it is an all metal hot end, send it to like 280, 285 and let it melt away all the badness. And hopefully, if you're lucky, it's gonna come off like a big drop of molasses, and you'll be able to reasonably salvage the hot end. Unfortunately, that silicone sock is out of here, but that is a really, really cheap insurance policy and an easy thing to fix when you look at the vast majority of the other components that could potentially be fried. Also, interesting little bed leveling sensor. I think this is an infrared sensor on the Tronxy. I've never worked with Tronxy before. I don't own any of their printers or looked at anything. Maybe that's something we should look at because I have a system like that on our laser cutter to figure out its home for its X and its Y. So kind of cool. Ways to prevent this. Make sure you watch that first layer. If you don't watch that first layer, you have a much higher chance of something like this happening. And come on. The first layer is the best part. It's the satisfying part. And honestly, throw a webcam on the printer. If you're not going to throw Octoprint on it, just throw a webcam on it, run it to an old computer or something, or a Wise Cam if you want to do that, and then have a smart plug, so if nothing else, you can just shut down the printer via power remotely. But as we've talked about before, if you are going to shut the printer's power off remotely, make sure that you turn it back on maybe 10 or 15 seconds later, so its cooling fans can continue to cool down the hot end. You can deal with that later on, but the one thing you don't want is that heat traveling up and heat soaking your heat sink, causing an even further problem from a clogging scenario. So if you're going to kill the power, just be safe about it. This one comes from a fan. They actually reached out on Reddit. I don't know what my first interaction was with them, but they said because of us, they bought a Prusa, and they're having some problems. They're having some bed adhesion issues. That's not fun. We've been there before. And initially when I saw this, I said, wait a minute, are you printing on the actual printed PCB on this, where it's the PCB heater? Because these lines just look so perfect. But in reality, I actually think that is from other prints that maybe did or did not stick. We messed around with decreasing the Z offset because that might have been the problem, but you know, this first layer did look okay. And this could be really frustrating, right? Alcohol didn't work. Hot water and soap didn't work. Both of those. Even a little acetone, which I know is not the best for the smooth sheets. It's really bad for the textured sheets on a Prusa, but it's not the best on the smooth sheets, but it's something to try to get that PEI to stick. Ultimately, I said, all right, if all of this fails, it's something that we do here. We wet sand the PEI. Now, if you don't have 2000 grit or above in stock, there'll be links in the description where you can get some, or hilariously, you can use melamine foam, otherwise known as a magic eraser. They are abrasive enough to polish the surface, but the polishing is actually adding micro cracks to it, you know, little micro scratches and that kind of thing. And 2000 grit or above sandpaper will do the same, both of which should be done wet. I like to use alcohol with a little bit of water mixed in there for some lubricant, and it seems to work really, really well, kind of opening the pores of the PEI itself. Now, remember, these plates, no matter who they're from, are wear items. Eventually, they will need to be replaced. Thankfully, they're not all that expensive. And most of them are double-sided anyways, so what the hell's the big deal? You just flip the damn thing over. But if you are going to sand it, just be careful not to apply a ton of pressure. The plate won't be as shiny anymore. It's going to get a little bit dull, but that's because you've effectively just put a bunch of scratches into it. If you have polishing compound for a car, I figure this would also work. A little wax on, wax off, young grasshopper, and you should be set. But for whatever this might be worth, do that at your own risk. It is not condoned by Prusa research. I've just found that if you don't want to fumble around with getting it to work perfectly, and you're just running into roadblock after roadblock after roadblock, and you're ready to rip the long hair out of your freaking head that you're gonna be shaving off sometime soon when your back is 100% fixed, make sure you guys get subscribed, because that's going to be a fun live stream. I don't know when yet. We're working on that. The sanding method is not particularly a bad way to do this. It's not a great way because, of course, it is providing excess wear to your build plate, but you must do it very, 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 very lightly. You want to make sure that you're not causing too much damage. You want to just kiss the surface. Just kiss it. If you can just literally drag the sandpaper across the surface without putting any excess pressure on it, do that in a few different directions, that'll be great. If you're using the magic eraser, you'll put a little elbow grease into it, wax on, wax off, and I think you'll have a much better case here. And at the same time, you're also kind of cleaning it, so bonus nachos, if you will. And, well, the magic eraser worked a treat. We can see that the first layer looks a lot better. Still a little bit of a way to go, but you can also see here that it is not as shiny as it is in any of these other photos. We can see some scratches here. I think that's just from basic wear and tear. But if you do only have one build plate, it might be a good time to look at buying another build plate. Whether you do buy one officially from Prusa, or you go look at buying one from another manufacturer like Wham Bam. By the way, code Musketeers for 10% off through May 31st, 2022. It's not too bad. The cost is insignificant when you look at the amount of time, effort, and energy that you're going to put into something like this. By struggling, potentially risking a $25 or $35 steel sheet is, well, it's insignificant value-wise as far as I'm concerned. Let me know what you guys think down in those comments. But that's all I have for you guys today here on PrintFix Friday episode 30. Let me know what your favorite fail is down below. Let me know if you think I got anything wrong. I'm particularly curious as to know other people's thoughts regarding those resin fails. But remember, if you have some fails that you're trying to get fixed, you can hit us up on all the social medias. They'll be somewhere here on the screen. You can always DM us on Twitter, Instagram, Facebook, send us an email to youtube@3dmusketeers.com, and if none of those options work, you can send a carrier pigeon as long as it grips it by the husk.
It's not a question of where he grips it. A 5-ounce bird could not carry a
17-pound 3D printer.
That's all I have for you guys today. Stay safe out there. Don't forget to call your loved ones, and as always, keep making awesome. Have a good one. I know for a fact that printer could catch fire because I did it in a controlled atmosphere years ago, and it definitely did. Hey, thanks so much for watching this video, and a massive thank you goes out to all of our Patreon and YouTube channel member supporters whose names are listed right next to me at the $5 tier and higher. Don't forget, whether it's us or any of your other favorite content creators, the beginning of the month is the best time to support people over on Patreon because they charge you at the first of the month every single month, regardless of the time that you joined the month prior. So now's the best time to join, and we have tiers as low as $1 that helps us make awesome videos all the time for you guys. Right below me will be the entire PrintFix Friday series, so if you're looking for something else to watch, go check that out. And right next to that will be the printer maintenance series, because if you're watching this, it might be time to clean up those printers. I will see you guys down in those comments, and in the next one, take care.